Okay, we're going to look at some of the practice problems for 9.3, negative and zero exponents. But before we look at any of these practice problems, I want you guys to write this down in your notes somewhere. If you have a negative exponent in the numerator, okay, so in the numerator of a fraction, it is going to be positive in the denominator, okay? So if I have, x to the negative fourth power, this is going to be written as 1 over x to the positive fourth power. Okay, so that's what that means. And the opposite is true as well. If I have a negative exponent in the denominator, well, then it's going to be positive in the numerator. Okay, so if I have the same thing, if I have 1 over 10 to the negative fifth power, well, I would write that as just 10 to the positive fifth power. Okay, and we wouldn't even need to write that over 1, but technically it is there. Okay, so let's look at some of these practice problems here. So the first one, 4 to the negative third power. So first of all, let's just recognize that any number can be written as a fraction over 1. So the number 10, for example, we could write as 10 over 1. Okay, so for number 1, this is 4 to the negative third over 1. So we want to just move this into the denominator and write this out as 1 over 4 to the positive third. Okay, same thing for number 2. We're just going to write this as 1 over 7 to the positive third. All right. What about with a negative number? We're just going to keep this as negative 2, but we're going to write it as negative 2 to the positive sixth in the denominator. Okay? All right, and then anything written to the power of 0 is equal to 1. All right? Let's skip around a little bit here. We have to remember that we still need to apply our exponent rules. So say for number 7 here, this is 2 to the negative third to the fifth power. So the power rule for exponents is to multiply the exponents. So what we're going to do is negative 3 times positive 5, which equals negative 15. So this is 2 to the negative 15th power, but we want to write this as 1 over 2 to the positive 15th power. That's the correct answer. Okay, pretty similar for 8. I'll let you guys do this one. Number 9, so like I said before, anything to the 0 power is equal to 1. So this is just 3 to the second times 1. So this is just 3 to the second. All right. Number 10, we're multiplying exponents. So the rule for multiplying exponents is to add the exponents. So we're going to do negative 5 plus negative 2, which is negative 7. So this is 4 to the negative 7th power, which we should write as a positive exponent. So 1 over 4 to the positive 7th. Okay. Number 11, we're dividing. So our rule is to subtract the exponent. So we're going to do 4 minus 7, which is negative 3. So this is 3 to the negative third power. And then we need to write this as a positive exponent. So it's going to be 1 over 3 to the positive third power. All right, number 12, still subtracting. So we're going to do negative 4 minus 5. So this is going to be 7 to the negative ninth. All right, you guys go ahead and finish that one out. 13, what's the error here? Let's see. They started with this. Okay, then they got 5 to the negative third power. What I always say is ignore their answer for a minute and just try to solve it yourself. If I were to solve this, I would recognize that we are dividing, so the rule is to subtract the exponents. So this is 4 minus negative 7, which is 11, right? This is 4 minus a negative, so really we change that sign. So this is the error. Here's where they messed up. This should be 5 to the 11th power. All right. Here's where it gets a little tricky here with 14 through 21. Some things we're going to keep in the numerator and some things we're going to move to the denominator. So again, anything can be written as a fraction over 1. We just can't have a negative exponent, so we're going to move this into the denominator. So this is going to be 1 over x to the positive fourth. So 15. If this is all in the numerator, the 2, this is like 2 to the first power. So that has a positive exponent. So that can stay in the numerator. We're just going to take out the y to the negative third and move that to the denominator. So the correct way to write this would be 2y to the positive third. All right. 16. What needs to move to the denominator? The 4 to the negative third needs to move, and the g squared is totally fine in the numerator because it is positive. So the correct way to write this would be g squared over 4 to the third. All right, I'll let you do 17, 18. These all look pretty. I guess I'll do 19. So it's a little bit different. So we have a fraction. So you could kind of think about this as like 2 in the numerator and the 3 is in the denominator. Okay. And we have a to the fourth power. That's positive, so that's okay. B to the negative fifth, that's negative, so we got to rewrite that. And C to the negative second, that's negative, so we got to rewrite that. Okay, so we're going to keep the 2 in the numerator. We're going to keep the a to the fourth power in the numerator. And then it's going to be 3, right? This 3 is going to stay in the denominator. Then we're going to write b to the positive fifth in the denominator and c to the positive second in the denominator. And that is correct right like that. All right, you guys can do 20. You guys can do 21. Just remember x to the 0 power, that's equal to 1. So it's essentially not even there, right? Because multiplying 2 times negative 3 times 1 is going to get you the same answer. So it's not going to affect the problem. Okay. All right, 22 through 25. We need to simplify, and then we need to make sure we only have positive exponents. So we still have to remember our rules here. So let's start with 22. If I'm going too fast, make sure pause the video, rewatch if you need to. I know I'm going a little bit quick today. So first thing we need to recognize is that we have 5 and 4. These are regular numbers. They don't have exponents, so we're just going to multiply these as normal. 5 times 4 is 20. And now we have some exponents, so we need to use exponent rules. We are multiplying, so the rule for multiplying exponents is we need to add the exponents. Okay, so x to the third times x is x to the fourth. All right, and then y to the negative fourth times y to the second would be negative 4 plus 2. So that's going to be y to the second power, or sorry, negative second power. All right, and we need to rewrite this with no negative exponents. So I want to write this as 20 x to the fourth over y to the positive second. Okay. 23 is pretty straightforward, just like that one. Just remember this is equal to 1. Here, I'll skip 24. You can do 24, and I'll do 25. So this is the power rule. So what we need to remember is that we kind of need to distribute out this 3. So this is 3 times 4 to the first power. So what we're doing is 1 times 3, which is 3. So this is 4 to the third power. Okay, then we do our next distribution. We do 2 times 3. So this is d to the 6th power. And then we do our last distribution, 3 times negative 5, which is negative 15. Okay, and what needs to stay in the denominator? What needs to move? I can keep the 4 to the 3rd and the d to the 6th. I just need to move out this h to the negative 15th and put it as a positive 15 in the denominator. Okay. 30, I'll get to that one later. Now we are dividing here, so we're subtracting exponents, but remember, we're going to keep our numbers, we're going to treat them as normal. So 12 over 4, that's 3. Okay. We're dividing, so we're subtracting exponents. So x over 8 divided by x to the 10th, we're going to subtract the exponent. So that's 8 minus 10 is negative 2. All right. And then y to the negative 5th over y to the 2nd, we subtract. So this is negative 5 minus 2, which is negative 7. All right, and the correct way to write this would be 3 in the numerator, and then we'll just move the x and the y to the denominator and write them as positive exponents. All right. Okay, you guys can do 27, you guys can do 28. They look fairly similar to 26, so you should be able to follow that. 30, which expression is equivalent to this here? Just remember this is equal to 1. So this is negative 4 times 3, which is negative 12. So this is negative 12 to the negative 2nd power. So this should be written as 1 over negative 12 to the positive 2nd power in the denominator, which would simplify to negative 12 times negative 12, which is 144. So it looks like D is the correct answer, 1 over 144. Okay, 33 or 31 through 34, putting in the missing exponents. So if we have a positive in the denominator, that means it was 4 to the negative 5th power. All right, you guys should be able to do 32, 33, and 34. 33 looks pretty tough, but it is to the 0 power. So what does that mean? You guys can give that one a shot. Don't overthink it. It's not as hard as it looks. All right, if you still need help with this, have your advisor call me down or Google Meet with me. All right, thanks.